Hello Year 10, so today's lesson is on using resources and sustainability, and this is a double lesson. So we're going to start off with this input through the video, and then there is an independent task for you to complete at the end, which should take about an hour for the second part. Okay, so first thing I'd like you to do is to consider these images here. And to have a think about what we use Earth's resources for and what resources are shown being used in these images. So pause the video here and complete those questions in your book, and let's see what you come up with. So Earth's resources are used by humans all the time, specifically to provide us with warmth, so we can see fuel there. We've got wood being burnt in a fire, or it might be the gas being burnt for your boiler at home. We use resources for shelter, so you can see a structure there in the woods, but equally your house, so the wood and the bricks and the steel and so on that go into building. We use resources for food, so we can see we've got resources from animals and plants there on that plate in order to provide us with food and the energy in there. And we use the resources for transport, so whether that's fuel to actually fuel the vehicles or the materials used to build those transport vehicles as well. So it's really important that we consider how we're using these resources in a way that is sustainable. Now on the screen here we've got some images. Top left is an image of some crude oil. We've got on the right there some different metal ores, so these are rocks that contain metal compounds. And at the bottom we've got some rock here, some limestone, which is used in all sorts of building and also production of materials and chemicals. So what do all of these images have in common? Have a quick think and pause the video. So each of these resources shown on screen here are what we call finite resources. Now finite is essentially the opposite of infinite. If something is finite, it means that it will run out at some point. Now we need to be able to define it really carefully. So when we're talking about finite resources, we say it's finite if it's being used up faster than it can be replaced. And if we carry on using finite resources, oh, apologies for the typo there, it should say finite resources, not finites. So if we carry on using them at the current rate, they will eventually run out. So in that blue box, that is the key definition for finite resources. This is the definition you need to memorise. So make sure you have written that down. So as well as the finite resources, we have resources that actually aren't going to run out, that we can keep using and keep replacing. So these kind of resources are called renewable resources. So this is something that we can replace at the same rate at which they're being used. And these resources will not run out. So again, the bit in the blue box is the key definition that you need to learn. So make sure you have written that down. Now have a think. Can you think of some examples of renewable resources that we use? Pause the video, see if you can come up with a list of 3 or 4, and then we'll carry on. So on the screen here we've got a few examples of renewable resources. Top right we've got some wood there. Now that wood there has been chopped up for burning, so we're using it as a fuel, but it is a renewable resource that we can use as a fuel. We can also use wood for building, so timber. And this is renewable because although we've got to cut down trees to use it, we can replant trees to replace them, and they grow relatively quickly. So a lot of the trees that we use for this will be fast growing pine trees. They can grow to full height in sort of 30 years or so, so it's quite a long time, but compared to producing crude oil, which takes millions of years to form, timber is quite a renewable resource. We can replace it quite quickly. On the top left there we've got some sugarcane. Now sugarcane is a grass really. It forms these really long stems. They have lots of sugar stored in there that we can then use. Now traditionally this has been grown literally just to get sugar that we can use in our food, but we have now developed ways of turning that sugar into a biofuel. So we turn it into ethanol and use that to make biodiesel, or you can just burn the ethanol directly. So that can be used as a fuel, and because it's not using a finite resource, there are benefits to that. We can replace that sugarcane very quickly. The height that that's grown to is just 1 year's growth, so we can get lots of fuel from that. And equally, the image at the bottom right there is also a crop used to make biofuels. So we just have to think about some of these finite resources we've got, and this graph here, it gives us a lot of information, but what it's showing is what will happen to the amount of different resources we've got there if we carry on using them at the current level. And this is showing levels that we'd expect in 2036 if we carry on using them as we are. So that's in 16 years. Now this was produced back in 2011, so this data is 9 years old. So some of this won't be as up to date, but this still gives us a good estimate of how much of each of these resources we've got left. And if we have a look at something like aluminium, it's showing that if we keep using it at this rate, then we've got enough aluminium for nearly 2,000 more years. So we've got lots of that. We've got things like graphite. It's a really important resource in terms of electrical components, and also it's used in lots of industry, but it's also used to make the lead in your pencils. So graphite by 2036 will have about 40 more years worth of that left, which isn't a lot, but you know, that's probably my lifetime, so I'll be alright. But for some of you that might run out in your lifetime. That's a significant issue. We've got things like oil, 18 more years by the time we get to 2036. So that's running out quite soon really, and we know oil takes millions of years to form, so that is a problem. But there are also some resources there that are expected to run out before we even get to 2036. So for example, gold. Now a lot of you will think of that in terms of being used for jewellery, but it's also a really important component in electronics. So it's used in a lot of the microchips and circuit boards and things in your laptops and phones, and that's expected to run out in the next 7 years based on this data. Now I don't know for sure if current data would tell us the same here, but we're certainly very low on resources like gold and lead and silver and tin. Now that's just showing if we carry on using it at the rate we are currently. Now this next graph shows us the estimates based on if the use of these resources continues to accelerate at the rate it was back in 2011. So in other words, we've been using all of these resources at a faster and faster rate, and if that rate of increase continues, then this shows a bit more of a dire situation than on the previous graph, because most of these resources are predicted to have run out by the time we get to 2036. Some of them will have for a little while longer, but you can see a massive difference, for example, in aluminium there. If we continue accelerating our use of aluminium at the current rate, then in 2036 we'll have 56 more years of it, whereas on the previous graph we were predicting nearly 2,000 more years. So obviously this is a big problem, and as chemists we need to consider alternative options, because clearly we can't just keep using these resources and keep doing the same thing, because at some point we're not going to be able to, because there won't be any left. So as chemists we have to consider different ways of using resources, or different sources that we can use. So this comes down to something called sustainability. Sustainability is about meeting the needs of the current generation without compromising the needs of future generations. In other words, using resources in a way that doesn't cause them to run out, that doesn't deplete them. And if we use up those finite resources, we have to think about what future generations can use. So chemists have a number of roles in this, including finding ways to reduce our use of finite resources, and also providing new products, synthetic products, that means man-made, that we can use instead of the natural or finite resources. Now that section in the blue box there is another very important definition that you need to know, so make sure you have that recorded in your book. So what I'd like you to do following on from this is some independent work to do with uses of products from plants. So this is all to do with sustainable resources that chemists have come up with using plants. Now on Go for Schools you'll find an article with that heading, Useful Products from Plants. You need to read it and pick out key information from that that you're going to use to design a poster on what we can do to be sustainable. Now this poster can use things beyond just this article. So if you have other knowledge, for example if you do geography, you might well have some extra ideas. If you want to do a bit of extra research, you can, but you don't have to. So the minimum is that you use the information from that article. Now your poster should include a mix of images and written text. Those images don't have to be drawn by you. You can find images online. Just make sure that you reference your sources or use ones that are stock images so that they're open source images. You can produce your poster by hand, or you can do it on a computer, whatever works best for you. You might find one way easier than the other, that's fine. You need to include at least 3 different examples of sustainable resources. You also should spend at least an hour on this, because this is a double lesson, so you should have plenty of time. Upload your work or a photo of it onto Teams, and if you have any questions or you get stuck at all, just send me a message on Teams or an email, and I'll help you out.